G'day. So what we're looking at today is we're looking at a second video between functions. Last video we looked at and we explored how this equation here works, or this rule works here. This here is the same kind of process. We're trying to find the area underneath a curve, but unlike this last video, these functions don't have a top and a bottom. They do have an area, and we're trying to find the area between these two curves. So we really can't use this formula. What we are going to be doing is we're going to be looking at a formula where we're going to add the two areas together. However, it is common when it comes to integration, find area of curves, to have to find some of those points of intersections. So right here, I have lower and upper points. Lower at 0, upper point at 5. However, that's not going to have any, I'm not going to be able to use that at all because these two functions are not above or below each other for that entire point. What I do know is that I have an intersection here. And that intersection, if I split that down, I can break this into area 1 and area 2, where area 1 will be directly under y equals x squared, and area 2 will be directly under y equals 20 minus 4x over 3. So that means I need to find out what this point is. So I have my upper point for area 1 and my lower point for area 2. And the best way of doing that is by simultaneously equating them against each other. So let's do that now. We get x squared is equal to 20 minus 4x over 3. Let's get rid of that fraction first. So multiply both sides by 3. 3x squared equals 20 minus 4x. And now we can turn this into a quadratic, and we know how to solve quadratics. So this here becomes x squared plus 4x minus 20 is equal to 0. Alright. Let's think of the way of solving these. There's a method called the cross factorization method. I'm not sure if you've seen this before. We'll quickly go over it now so you can see how it works. Is we look for the factors that make up the first term, and then we look for factors that make up the last term. And when we cross multiply them, the sum of those two answers should give me this middle term. So it's an altercation of splitting a term. So let's look at that here. So what we could do here is we say, well, 3x squared is made up of x and 3x. And now I want to think of all the factors of 20. So all the factors of 20 are 1, 2, 4, 5, 10, and 20. And they could be negative as well, positive or negative. In this case, one of those numbers here have got to be negative, one of them has got to be positive. And when I multiply them with the equivalent factors of 3x squared, when I add that product, I should get plus 4. So let's think about this. Let's do a process of elimination. There's no way that I can get 1 and 20 to give me plus 4. Is there a way of getting 5 and 4? Well, let's see. 5 times 4, 5x. We get 7x, 7x take away 5x. I'm not going to get anything there, even if I flipped it around. So the only way I'm going to be able to get these answers is by doing 10 and 2. So we can manipulate this. One of them has to be negative. So how about I make this 10 and I'll make this 2. So therefore I've got 10x and 6x. If I make this subtraction, when these two multiply against each other, let's see what we get. We get 10 times x, which is 10x. 3 times negative 2 gives me minus 6x, which gives me 4x, which I'm looking for. And 10 times negative 2 is negative 20. So I found out what two numbers I can use here that multiplies with its corresponding factors of 3x squared to get the 4. And now it's just a matter of coming across. And these become your factor pairs. So as we look at this here, our factor pairs become 3x plus 10 and x minus 2. So we can now rewrite this here as equal 0. So let's get rid of all that. And we want to find what, when we equate it to 0, is going to give us that point. So therefore, x is equal to negative 10 on 3, or x is equal to 2. Well, looking up here, negative 10 on 3 won't fit, but 2 will. So I can rewrite this and say that I've got my point of intersection when x is equal to 2. So now I'm at a point where I can now start integrating the area 1 and integrate area 2. So let's integrate area 1 first. So if we integrate area 1 first, we're going to have the integral of 2 to 0 x squared with respect to dx. Alrighty, let's integrate this out. So we get x to the power 3 over 3, 2 to 0. Let's plug that in. We know that 2 cubed equals 8, 8 on 3, so we get 8 on 3 minus 0. So therefore, area 1 is equal to 8/3. We've worked out what our first area is. Let's now work out what our second area is going to be. So our second area, or area 2, is a little bit more complicated. We're going to rewrite this as 5 to 2, but I'm going to rewrite it as 1/3 20 minus 4x dx. And the reason why I'm doing that is so that way I can actually pull that 1/3 out. Because remember, one of the rules that we have in terms of integration is if I have the integral of k fx dx, this can be rewritten as k the integral of fx dx. And I can do that same thing here. I'm not integrating that constant, I'm integrating the function behind it. So if we rewrite this, we can bring the 1/3 out, 5/2, 20 minus 4x dx. And now I'm ready to start integrating. 1/3 is equal to 20x minus 4x squared over 2, 5 and 2. Alrighty. Let's now finish up and start solving this. So if we start solving this, we end up getting, and let's just line this down so I'm not running out of space, 1/3 20 by 5 minus, well, let's write that 2 now because I can simplify that down. 2 by 5 squared minus, I'm going to put big brackets around that because we're going to multiply at the end. 20 by 2 minus 2 by 2 squared. So if we work this out, what do we get? We get 20 times 5, which equals 100, minus 50. So we get 50 minus 20 times 2 is 40, minus 4 times 2 is 18. 20 minus that, yep, do I get 18? 32, sorry, because it's 40, isn't it? So I get 18. So therefore, we can now fix this up and we get 1/3 times 18